Welcome to all my viewers. In our session for today, we are going to discuss about finding the Laplace transform of a function f of t is equals to cos hyperbolic 7t using the first principle. When it comes to the first principle, the first thing that we need to understand is about the formula. And when it comes to the formula, we know that the Laplace transform of our function f of t is equals to integration with respect to our limit, exponential negative st we multiply by our function f of t, and our integration is with respect to dt. To mean that in our first step, whenever we are having our function f of t, we are going to replace with cos hyperbolic 7t. That is in our first step. So when we come here, we are going to have the Laplace transform of cos hyperbolic 7t, which is equals to integration with respect to our limits, exponential negative st we multiply by cos hyperbolic 7t, and our integration is with respect to dt. Up to this point now, we need to change the cos hyperbolic 7t into an exponential, and by changing cos hyperbolic 7t into an exponential, we understand that cos hyperbolic x is equals to a half into exponential x we add to exponential negative x. When we are having cos hyperbolic 7t is going to be equals to a half into exponential 7t we add to exponential negative 7t. We've already converted the cos hyperbolic 7t into an exponential. Let us now get back into our working, whereby we say that the Laplace transform of a function f of t is going to be equals to integration with respect to our limits, exponential negative st we multiply by a half into exponential 7t we add to exponential negative 7t, and our whole integration is with respect to dt. We are going to factor out a half because it is not a term of dt, and we open the bracket. By doing that, we are going to have the Laplace transform of our function f of t is going to be equals to a half, an integral with respect to our limits. We come and take exponential negative st we multiply by exponential 7t we add to exponential negative 7t we multiply by exponential negative 7t, and our integration is with respect to dt. From this point, we can come and use the loss of indices to simplify whatever we are having here and at this point. By doing those two, we understand that when the bases are equal, we are going to take one of the bases and we add the powers when it is a multiplication. And that is what we are going to do at this point and at this point. To mean that we are going to have the Laplace transform of our function f of t is going to be equals to integration, a half integration with respect to our limits, exponential. Here we are going to have on the numerator a negative of s, we add to 7. We factor out our term of t on the numerator. On this side we are going to have exponential negative of s, we subtract from 7, we multiply by t. And our whole integration is with respect to dt. Let us now do away with the integral sign, whereby we are going to have the Laplace transform of now our function f of t is going to be equals to a half into, when we integrate whatever we are having here, we are going to have exponential negative s, we add to 7 t all over negative s, we add to 7. And here we must have our limit, the upper class limit and the lower class limit. We come and add 2. When we integrate whatever we are having here, we are going to have exponential negative s, we subtract from 7 t. Everything is going to be all over negative s, we subtract from 7. And our integration was with respect to the upper class limit and the lower class limit. Let us now separate the denominators from the numerator and we work out with the limits. So the Laplace transform of our function f of t, we understand, is going to be equals to a half into negative s, we add to 7, we come and multiply by exponential negative s, we add to 7. And here we are going to have our limits. We come and add 2. On this side we are going to have 1 all over a negative of s, we subtract from 7. We multiply by exponential negative s, we subtract from 7t. And here we have our limits. Let us now do away with the limits, that is the upper class limit and the lower class limit, whereby we can say the Laplace transform of our function f of t is going to be equals to a half into 1 all over negative s, we add to 7, exponential negative s, we add to 7. We come and insert the upper class limit here. We subtract from exponential negative s, we add to 7. We insert our lower class limit. And it is always quite important to work out with the brackets. We come and add 2. When you work out with the bracket, is going to make your work easy by avoiding some mistakes. On this side now we are going to have 1 all over negative s, we subtract from 7. We come and multiply by exponential negative s, we subtract from 7. We come and insert our upper class limit. We subtract from exponential in bracket negative s, we subtract from 7. And we come and insert the lower class limit. We close our bracket. At this point now, from this point now, we can come and say the Laplace transform of our function f of t is going to be equals to a half into 1 all over negative s we add to 7, we multiply by an exponential raised to a power of an infinity. We understand is going to be 0. We subtract from exponential raised to a power of 0 is equals to 1. We come and add to 1 all over negative s, we subtract from 7. Exponential raised to a power of 0, raised to a power of an infinity is equals to 0. We subtract from exponential raised to a power of 0 is equals to a negative of 1. We close our bracket. Up to this point now, the negatives that we are seeing within this bracket are going to affect the denominators. And here this negative also is going to affect whatever we are having there on the denominator. To mean that we are going to have the Laplace transform of our function f of t is going to be equals to a half into, here we are going to have 1 all over s, we subtract from 7, we add to 1 all over s, we add to 7. Let us now simplify these two brackets, and by simplification of whatever we are having here, we are going to take our cross multiplication, whereby the Laplace transform of our function f of t is going to be a half into 1 multiplied by this one, we multiply by whatever we are having there, s we add to 7, we add to 1 into s we multiply by 7. On the denominator, we are going to take s multiplied by s, we are going to have s squared, we add to 7s, we subtract from 7s, we subtract from 49, because negative 7 multiplied by that is going to be 49. The Laplace transform of our function f of t is going to be equals to a half into, we open the bracket on the numerator, s we add to 7, we add to s, we subtract from 7, all over, on the denominator we are going to have s squared. This one is a positive, this one is a negative. They are going to cancel out, we remain with 49. From this point now, we can simplify the numerator. The Laplace transform of our function f of t is going to be equals to into, here now we are going to have 2s all over negative, this one is a positive, this one is a negative, they are going to cancel out. S squared we subtract from 49. At this point now, this one and this one will cancel out, and we are going to have the Laplace transform of our function f of t is going to be equals to s all over s squared we subtract from 49. To mean that the Laplace transform of cos hyperbolic 7t using the first principle is equals to s all over s squared we subtract from 49. And this is how you go about finding the Laplace transform of cos 7t using first principle formula. Thank you for your time.